Anyway, he said, as he continued to casually drop an absolute bomb on the entire field of physics with his theory of relativity. He assumed the speed of light is constant because it arises from two other constants. He also assumed the laws of physics are the same for everyone, regardless if moving or at rest. Now think about it. If two people turn on a flashlight but one person is standing still while the other person is on a moving train, wouldn't the person standing still see the other person's light as going faster than the speed of light? The reality is, no, it would be the same as their own flashlight. That's impossible, except if time passes slower for that person from the perspective of this person. In other words, if the speed of light is constant, time must be relative. Also, gravity is not actually a force, sorry Newton, but rather a consequence of masses bending spacetime. Einstein thought the universe is a mesh of space and time, and anything with a mass bends this fabric. Also, all objects move freely on a straight line when moving through space. Gravitation is simply the result of objects following these bent lines which appear straight to them. If you have a hard time understanding this, you can imagine two people on Earth walking in parallel straight lines. Now imagine one standing on the east coast and one on the west coast of the US. If they both walk north, eventually they'll meet at the North Pole. Because of the curvature of the Earth, they ended up at the same point even though they both walked straight relative to themselves. Oh yeah, by the way, energy and mass are kind of the same thing, he added, which explains why atom bombs are so freaking powerful. According to this formula, even just tiny atoms can release a humongous amount of energy by giving up just a fraction of their mass during fission. What is fission? It's the same thing Oppenheimer used to make this thing go boom. You see, there's two main ways to gain energy from changing nuclei, fission and fusion. Fission aims to split the nucleus of an atom into two or more smaller nuclei, which is most often achieved by blasting the core with neutrons. Fusion is the opposite, where you combine two smaller nuclei to get one bigger one. The energy came from something we call a mass defect, where the resulting nucleus is lighter than the starting nuclei. This missing mass is what was converted to energy during fusion. Fission and fusion are cool, but you gotta be careful or you might just blow up the planet.